G'day, my name is Damien Beard, and this week we're looking at model-based systems engineering. So the idea of a model was introduced to us by John Hosking, and the idea of a model is not new. He showed us it's already used in maths, it's already used in biology, it's already used in chemistry. In fact, it's used in every science and engineering field that we have at the moment. And in computing, at the moment, it looks like it's trying to phase out the document-based approach. At its heart, model-based systems engineering is about communication. It bridges the gap between the problem domain and the implementation domain. Now, communication, just like ethics, is one of these topics that keeps cropping up throughout this course. We saw it last week with systems architecture, and I think it just really shows that in that first week when it was established that software engineering is about communication, it is because every part of it is. You cannot get away from it. And model-based systems engineering, it just reinforces that. So building on that, model-driven engineering, it's all about viewpoints. You don't just create one model, you create several related models and diagrams, and what you build to show the developers will be completely different to what you build to show your upper management. One of the current goals of model-driven engineering is to create standards throughout the industry. Currently there aren't any, but slowly some pseudo-standards are beginning to emerge. We've seen in the past how standards can simplify a system and how it can help enhance the communication between professionals because they have a common set of language with which they can speak, so communication can become clear and unambiguous. One of the hardships that I think that they're going to face with trying to create standards with the model-based approach is that every system is different, every model is different. You're not going to be able to have a hard and fast set of tools that are going to be able to be related to every single software system. But I suppose that's just something they can work on. If they can create that pseudo set, then it can be adapted a little bit, I guess. So we've seen this week how a model should be simulated and automated and show the relationships within a system. But one thing that's interesting about software that we've already seen in this course is that software is unique in that if you were to build something which exactly described what the software did step by step, then you've already built the software to begin with. So rather than the model exactly emulating what the software is that it wants to be building, instead the models we build are going to be more like prototypes, scaled down versions of the ultimate piece of technology that we're going to be making. In the blog this week, I actually include some links to some of the prototypes that I've made for my COMP3530 course, which is the software engineering project, the year-long project. So I'm showing that we already at ANU as software engineering students are using this sort of approach. In fact, at ANU, we've already had a whole course about building diagrams and models for systems. That's COMP3530. So we've seen state diagrams. I don't know how we're going to be able to read this, but we've seen state diagrams, class diagrams in every single course, and that was a hierarchical one. State transition diagrams. This idea of models and creating diagrams and creating documentation, this is actually something that isn't new to us. This is something that we've been doing the whole way through our degree. But this is probably the first time we've seen it formalized in such a way and have been able to see the advantages of doing it like this. And finally, I wanted to ask the question, so what do you save by a model-based approach as opposed to a document-based approach? Do you save time? No. But do you save money? No. But what you do save on is final quality at the end of your project. This is a point that Clyde brought up in the panel, in that, look, model-based systems engineering is not about saving time and money. It's about creating the best product you can at the end. And that is really the advantage over documentation-based, which has other priorities, other admin priorities. This approach looks at how can we make the best product in the end? How can we deliver the most satisfaction to our customers? Which then ties back into systems thinking. It's not looking at the analytical parts. It's looking at, is this system as a whole, how can it deliver satisfaction at the end for our stakeholders, which ties into the rest of the course that we've seen up until this point. Anyway, that's all for me, so enjoy the blog and I'll see you next week.